Hello. So today I will start with a new course. It's called Essential Google Cloud Infrastructure Foundation. So this is the first of three courses, which are the Essential Google Cloud Infrastructure courses. I was considering also this one and this one. So there are four courses about the Google Cloud infrastructure. Then we have other courses which are of course related, but in this case we have like a specific focus on uh, how the services are provided, how to configure them. So we'll dig into these topics. I already completed the introductory course, which explains how hands-on lab work, the course which advises you how to pick the right material for you. In my case, all the material is useful. And then we have the Google Cloud Fundamentals, which is an introduction course that explains which are the core services when using Google Cloud, those who will be used in all the contexts. Whatever you do, you will use VPC, compute engine, JKE with high probabilities. Of course, you will use IAM, and all this stuff is just introduced here. It's not going deep. However, it's a good way to start having a broad image of what the core of GCP is. Okay, then this is the natural continuation of those courses, the 4, 5, 6, and 7. Therefore, we'll start today with the course 4 of this learning path, which I will remember you, Cloud Architect, Cloud Professional Architect. I want to take the certification for this learning path. Recently, I've been promoted to the Gold League among the profiles which are practicing any learning path. I've earned these 2 badges here. They're not, these badges here are just for fun, I think. Or maybe you can share them somewhere, but they're not, I don't give them such a high value. In fact, they are associated with this channel account, which is not my personal profile, therefore they're just for fun. Okay, so if we look at the activities, I had these laboratories. First was just a tour. Then I practiced I've tried my first marketplace solution. You just can deploy solutions from the marketplace with a few clicks. And then I practiced something about VPC networking and compute engine connectivities. Then I've practiced with cloud storage and cloud SQL. And then I practiced with the serverless application in Cloud Run. So if you're interested, you can find all these laboratories in, let's see. When you go to a learning path, you will have some hands-on labs. In particular, I've done mainly in this one, I had a lot of hands-on labs. In this course here, there are no hands-on labs, it's just theory. Okay, therefore, this is 6 hours and 45 minutes. Let's see one thing. This was 5 hours. And I completed it in 5 hours. I think I did 5 episodes about this course here. Therefore, it's a good estimation. So I imagine it will take me like 6-7 episodes of 1 hour each to complete this. So, Cory Adeirioma. Hi, I'm also taking the professional cloud architect exam. I saw your post on LinkedIn. Would love to watch. Great comment. And feel free to put anything you want, any comment. I will try to watch a bit the comments and to interact with you. However, I'm studying, so I will not be continuously watching the chat. In any case, yeah, each like 15 minutes, maybe I will have a look. So if you have any doubt, any curiosity, maybe something you want me to try so you can see it and then try it by yourself, just let me know. This is I would love to create a space where people can practice together. I'm not sure how. Maybe there are some kind of laboratories where we can do something in team. We'll see. For now, I need to take a bit of routine with these concepts. So essential cloud infrastructure foundation. Let's go. Okay, so this course needs 30 credits. I have a subscription. You can see I have this subscription here. It says manage subscription because I have it, but I have I have in intention to buy this other subscription. I found it recently. I'm not sure if you're maybe interested in it. It's interesting because, well, it gives a lot of credits, which allow you to make tests in the labs and whatever. Then it gives you a certification voucher. So you pay $300 in 1 year, then you get up to $200 to take the certification exam, because you have to pay to do the exam. And if I'm not wrong, it's around $200 the value for the certification you want to do, the cloud professional architect. And then you have also 500 additional Google Cloud credits per year after successfully passing a certification exam. So you will still have credits to, test and play around with tools, because in the end, you never finish to learn. You will always need a personal account where you maybe need to practice a bit. And then, this is super cool. You have one-to-one consultations with Google Cloud experts. So if you do not understand or if you want to have a deeper look into some kind of architecture or technique, you will have this opportunity. Plus, it's not written here. Maybe if you do like this, you can see that it gives you access to some Google events. Some Google events where you can meet other experts and architects. But I can't see it here. I've seen it somewhere, inspecting a bit what's this offering. But so sorry for going again on a different topic, but it was interesting when I discovered it, so I wanted to share with you. Okay, well, let's see. This accelerated on-demand course introduces participants to the comprehensive and flexible infrastructure and platform services provided by Google Cloud, with a focus on compute engine. So, compute engine, this is the most important element. Through a combination of video lectures, demos, and hands-on labs, participants explore and deploy solution elements, including infrastructure components such as networks, virtual machines, and application services. So we'll practice on these, which are the core elements, the compute engine, virtual machines. We will create networks and configure them, the VPCs and application services, which will be launched on the virtual machines. And yeah, it's always interesting. You will learn how to use the Google Cloud through the console and Cloud Shell. You will also learn about the role of a cloud architect, approaches to infrastructure design and virtual networking configuration with virtual private cloud projects, networks, subnetworks, IP addresses, routes, and firewall rules. Okay, so it's important to always remember that all the compute engine resources in the end are just some computational resources which are accessible through networks. Therefore, you cannot avoid studying VPC, virtual private clouds, when using compute engine, because everything you do with compute engine in the end will need to pass in and out through a VPC. You will need to share the compute engine resource and its the process it's running. You will need to share it inside or outside the VPC. You will need to configure in the best way the project and the networks and the subnetworks. So it's like these are topics which cannot be divided. When you complete this course, you can earn the badge displayed here. View all the badges you have earned by visiting your profile page. Boost your cloud career by showing the world the skills you have developed. Yeah. So this course has 1, 2, 3, 4, 5, 6, 5 sections, modules. So let's go with the introduction. I will go a bit faster.
Hello, I'm Philip Meyer.
And I'm Elaine Biddle. We're both course developers at Google Cloud, and we want to welcome you to Architecting with Compute Engine, a series of 3 courses.
Before we start using all of the different services that Google Cloud Platform or GCP offers, let's talk about what GCP is. When you look at Google Cloud, you'll see that it's actually part of a much larger ecosystem. This ecosystem consists of open source software, providers, partners, developers, third-party software, and other cloud providers.
Google is actually a very strong supporter of open source software.
That's right. Now, Google Cloud consists of Chrome, Google Devices, Google Maps, Gmail, Google Analytics, G Suite, Google Search, and the Google Cloud Platform. GCP itself is a computing solution platform that really encompasses 3 core features: infrastructure, platform, and software.
This map represents GCP's global infrastructure. As of this recording, GCP's well-provisioned global network connects over 60 zones to over 130 points of presence through a global network of fiber optic cables.
And Google is continuously investing in this network with new regions.
Okay, so these informations here may look like just a bit of marketing, but it's not. In the sense that in the exam, you can find some questions about these type of concepts. Like the points of presence, the global network of fiber optic cables, which are Google's cables. It's important to understand that Google provides really low level infrastructures. They can connect your on-premise infrastructure with the Google Cloud infrastructure by providing their own cables. So it's interesting to remember this, and it's interesting also mentally to have this fraction in infrastructure, platform, and software. The infrastructure is mainly all the hardware, the computers, the cables, the racks, the power, all the middle hardware. And then the platform is all the components of virtualization, which allow you to avoid thinking about virtualizing your operative system, virtualizing all the low-level software, let's say. And then you have also the software in case you need like to run containers. You already have a part of software which will be arranged for you. All the requirements for the container, all the libraries will be available, provided there. Therefore, you have these three cloud stacks, I would call them. On top of this
points of presence and subsea cable investments. On top of this infrastructure, GCP uses state-of-the-art software-defined networking and distributed systems technologies to host and deliver your services around the world. These technologies are represented by a suite of cloud-based products and services that is continuously expanding.
Now, it's important to understand that there is usually more than one solution for a task or application in GCP. To better understand this, let's look at a solution continuum.
Google Cloud Platform spans from infrastructure as a service, or IaaS, to software as a service, or SaaS. You really can build applications on GCP for the web or mobile that are global, auto-scaling, and assistive, and that provide services where the infrastructure is completely invisible to the user. It is not.
So what I was mentioning, it's something that they already said in other courses, so this is why I was remembering them. Infrastructure as a service is providing all the IT operations and system operations, which then coincide with platform as a server, because then you have the servers and VM instances which are managed. And then DevOps, because you have the deployment of clusters, and then low ops, which mean they will take care also about the libraries and the updates of your systems which will run your applications. And then you have all the serverless auto-scaling with no operations. Basically, you just need to write your code. So you can go from one range to the other.
Just that Google has opened the infrastructure that powers applications like Search, Gmail, Google Maps, and G Suite. Google has opened all of these services that make these products possible and packaged them for your use.
Alternative solutions are possible. For example, you could start up your own VM in Google Compute Engine, install open source MySQL on it, and run it just like a MySQL database on your own computer in a data center.
Or you could use the Cloud SQL service, which provides a MySQL instance and handles operational work like backups and security patching for you using the same service as Google does to automate backups and patches.
You could even move to a NoSQL database that is auto-scaling and serverless, so that growth no longer requires adding server instances or possibly changing the design to handle the new capacity.
This series of
So let's see if there's some interesting concept here. I mean, it's interesting, but something we may need to take note of. Could start your own VM, computer, install open source my own, it's around like MySQL database on your computer in the center, or you could use the Cloud SQL service, which provide blah, 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 like backups and You could even move to an SQL that is auto-scaling, no longer requires adding several instances, blah, blah, blah. This series, of course, is focused on the infrastructure. So, okay, we are going to have a good look at IT ops system operations, which include the resources and the servers and the VM instances.
Install open source MySQL on it and run it just like a MySQL database on your own computer in a data scaling and serverless, so that growth no longer requires adding server instances or possibly changing the design to handle the new capacity.
This series of courses focuses on the infrastructure. An IT infrastructure is like a city infrastructure. The infrastructure is the basic underlying framework of fundamental facilities and systems such as transport, communications, power, water, fuel, and other essential services. The people in the city are like users, and the cars and bikes and buildings in the city are like applications. Everything that goes into creating and supporting those applications for the users is the infrastructure. The purpose of this course is to explore as efficiently and clearly as possible the infrastructure services provided by GCP. You should become familiar enough with the infrastructure services that you will know what services do and how to use them.
We won't go into very deep dive case studies on specific vertical applications, but you'll know enough to put all the building blocks together to build your own solution. Now, GCP offers a range of compute services. The service that might be most familiar to newcomers is Compute Engine, which lets you run virtual machines on demand in the cloud. It's Google Cloud's infrastructure as a service solution. It provides maximum flexibility for people who prefer to manage server instances themselves.
Google Kubernetes Engine lets you
Okay.
run containerized applications on a cloud environment that Google manages for you under your administrative control. Think of containerization as a way to package code that's designed to be highly portable and to use resources very efficiently. And think of Kubernetes as a way to orchestrate code in containers.
App Engine is GCP's fully managed platform as a service framework. That means it's a way to run code in the cloud without having to worry about infrastructure. You just focus on your code and let Google deal with all the provisioning and resource management. You can learn a lot more about App Engine in the Developing Applications with Google Cloud Platform course series.
Cloud Functions is a completely serverless execution environment, or functions as a service. It executes your code in response to events, whether those events occur once a day or many times per second. Google scales resources as required, but you only pay for the service while your code runs. The Developing Applications with Google Cloud course series also discusses Cloud Functions. Cloud Run
Developing application with Google Cloud course series of this. Okay.
managed compute platform that lets you run stateless containers via web requests or pub-sub events. Cloud Run is serverless. That means it removes all infrastructure management tasks so you can focus on developing applications. It is built on Knative, an open API and runtime environment built on Kubernetes that gives you freedom to move your workloads across different environments and platforms. It can be fully managed on Google Cloud, on Google Kubernetes Engine.
It's interesting, this thing here about Cloud Run, which is built on Knative. Knative, which is an open source project, which allows you to build serverless and event-driven applications. So you have these clusters of computational power where you can launch containerized applications, and based on calls, on requests, on events, pub-sub events, for example, your resources will execute a specific configuration of a container. Therefore, you have this stateless, serverless environment where you can run microservices, basically.
Or anywhere Knative runs. Cloud Run is fast. You can automatically scale up and down from 0 almost instantaneously. And it charges you only for the resources you use, calculated down to the nearest 100 milliseconds. So you'll never pay for your over-provisioned resources. In this series of courses, Compute Engine will be our main focus. The Architecting with Google Compute Engine courses are part of the Cloud Infrastructure Learning Path. This path is designed for IT professionals who are responsible for implementing, deploying, migrating, and maintaining applications in the cloud. The prerequisite for these courses is the Google Cloud Platform Fundamentals Core Infrastructure course, which you can find in the link section for this video. The Architecting with Google Compute Engine series consists of 3 courses.
Essential Cloud Infrastructure Foundation is the first course of the Architecting with Compute Engine series. In that course, we start by introducing you to GCP and how to interact with the GCP console and Cloud Shell. Next, we'll get into virtual networks, and you will create VPC networks and other networking objects. Then we'll take
So Essential Cloud Infrastructure Foundation is the first course of Architecting with Compute Engine series. We start by introducing to GCP and how to interact, blah, blah, blah. Next, you will get into virtual networks, and you will create VPC networks and other networking objects. Then we'll take a deep dive into virtual machines, and you will create virtual machines using Compute Engine.
a deep dive into virtual machines, and you will create virtual machines using Compute Engine.
Essential Cloud Infrastructure Core Services is the second course of this series. In that course, we start by talking about Cloud IAM, and you will
Essential Cloud Infrastructure Core Services, okay.
administer identity and access management for resources. Next, we'll cover the different data storage services in GCP, and you will implement some of those services. Then we'll go over resource management, where you will manage and examine billing of GCP resources. Lastly, we'll talk about resource monitoring, and you will monitor GCP resources using Stackdriver services.
Elastic Cloud Infrastructure Scaling and Automation is the last course of the series. In that course, we start by going over the different options to interconnect networks to enable you to connect your infrastructure to GCP. Next, we'll
Elastic Cloud Infrastructure, okay. So these are all the courses going beyond the 3 or 4 courses which I've highlighted before.
go over GCP's load balancing and auto-scaling services, which you will get to explore directly. Then we'll cover infrastructure automation services like Terraform, so that you can automate the development of GCP infrastructure services. Lastly, we'll talk about other managed services that you might want to leverage in GCP.
Now, our goal for you is to remember and understand the different GCP services and features, and also be able to apply your knowledge, analyze requirements, evaluate different options, and create your own services.
And that's why these courses include interactive hands-on labs through the QuickLabs platform. QuickLabs provisions you with a Google account and credentials, so you can access the GCP console for each lab at no cost.
Let's go. So this is the end of this introductory module. Welcome to Essential Cloud Infrastructure Foundation. Okay, so I will create a folder where I download all this material. This is the course 4 of the learning path. It's called Essential Cloud Infrastructure Foundation. And I will download this in the same folder I just created. And here, what we have, welcome to Essential Cloud Infrastructure Foundation. The lecture you just watched is focused on 3 architecture courses. Okay. So we are here, then we will have this, of course. In this course, we start by introducing you to Google Cloud and how to interact. Okay, oh, these are basically all the things the girl was mentioning in the video.
In this module, we will provide you with an introduction to GCP by building on what you learned about the GCP infrastructure from the course introduction. This module...
Okay, so we have a lot of labs here. Nice. It's a practical course. I love it. We have 1, 2 labs. I mean, it's not a lot.
is focused on how to interact with GCP. In the labs of this module, you will explore both the GCP's graphical user interface and its command line interface. You will also deploy a solution from the GCP marketplace without having to manually configure the software, virtual machine instances, storage, or network settings. To complete your learning experience, I will provide a quick demo of projects. Let's get started.
Okay.
There are 4 ways you can interact with Google Cloud. And
this stream is already half an hour nearly. So let's go.
we'll talk about each in turn. There's the Google Cloud Console.
Sorry, I will lower speed here.
There are 4 ways you can interact with Google Cloud, and we'll talk about each in turn. There's the Google Cloud Console, Cloud Shell and the Google Cloud CLI, the APIs, and the Cloud mobile app. The Google Cloud Console provides a web-based graphical user interface that you access through console.cloud.google.com. For example, you can view your virtual machines and their details as shown on the top. If you prefer to work in a terminal window, the Google Cloud CLI provides the Cloud command line tool. For example, you can list your virtual machines and their details as shown on the bottom with the Cloud Compute Instances List command. Google Cloud also provides Cloud Shell, which is a browser-based interactive shell environment for Google Cloud that you can access from the Google Cloud Console. Cloud Shell is a temporary virtual machine with 5 GB of persistent disk storage that has the Google Cloud CLI pre-installed. Throughout this course, you will apply what you learn in different labs. These labs will have instructions to use the Google Cloud Console, such as on the navigation menu, click Compute Engine then VM Instances. Let me dissect these instructions. First, within the console, you will click on the icon with the 3 horizontal lines, which is the navigation menu, as shown on the left. This opens a menu as shown on the right. All of the major products and services are listed on this menu. Then, within the menu, hover over Compute Engine to open a submenu. Finally, click on VM Instances on the submenu. You will get an Android or iOS device. For example, Python. Admin APIs offer functionality for create using a globally unique name for a cloud storage bucket. In addition to the Google Cloud CLI, you can also use client libraries that enable you to easily create and manage resources. Google Cloud client libraries expose APIs for 2 main purposes. App APIs provide access to services, and they're optimized for supported languages such as Node.js or Python. Admin APIs offer functionality for resource management. For example, you can use admin APIs if you want to build your own automated tools. The Cloud mobile app is another way to interact. For example, you can use...
Sorry, therefore we have the Google CLI, the client libraries for all the languages, and then the APIs.
Admin APIs if you want to build your own automated tools. The Cloud mobile app is another way to interact with Google Cloud. It allows you to manage Google Cloud services from your Android or iOS device. For example, you can start, stop, and SSD into Compute Engine instances and see logs from each instance. You can also set up customizable graphs showing key metrics such as CPU usage, network usage, requests per second, and server errors. The app even offers alerts and incident management and allows you to get up-to-date billing information for your projects and get
the next one.
Slides are great for explaining concepts, but let's apply what we just talked about. In this first lab, you'll explore the GCP interface that is the entry point of the graphical user interface that's called the GCP console. Within the GCP console, you will create a storage bucket in Cloud Storage, which is Google's unified object storage. Then you'll repeat the same task using Cloud Shell, which is the command line interface in GCP. I encourage you to develop familiarity with both the GCP console and Cloud Shell, and to become comfortable moving back and forth between them.
Okay, so this looks like a simple lab. I just put start. Now I will be able to open the incognito window here. Okay. Before sharing with you, I will just log in with these credentials. These credentials here, yeah. So want it in English. Okay. So it's Google Cloud Console. No. Wait. Yeah, I agree. And why it's not showing anything? This is kind of strange. Dashboard, Quick Labs. Why it's not showing this? Okay, now I can show you. Perfect. So what happens? What is my first task? Okay. So the first task is you create a bucket. Oh, just a second. I need to do something in my Windows taskbar so I can see. I don't want to group my tabs. Never. Okay, so now I have, yeah, I can go smoother way. So first instruction. In the Cloud Console navigation menu, Cloud Storage Buckets, click Create. For name, type a globally unique bucket name, leave all the values as their default, click Create. If prompted, public access will be prevented, click Confirm. Okay, so I will use my project ID as name for the bucket they're asking me to create. So let's go in Cloud Storage Buckets, create name. I just put there, okay. And then click Create. Yeah. Enforce public. What was saying it? Confirm. Nice. Expose feature in the Cloud Console. Explore feature in the Cloud Console. Okay, so the Google Cloud menu contains notification icons, sometimes feedback from the underlying commands. Okay, click, check my progress. We have it. Therefore, second task. In this section, you explore Cloud Shell and some of its features. You can use the Google Cloud Shell to manage projects and resources via command line without having to install the Cloud SDK and other tools in your computer. So if you want to run the Cloud Shell commands from your machine directly, you need the Cloud SDK. Instead, if you don't want, you can just run. We'll see how. Cloud Shell provides the following: temporary compute engine VM, command line access to the instance via browser, 5 gigas disk storage, pre-installed Cloud SDK and other tools, G-Cloud for working with compute engine and many other cloud services, G-Cloud Storage for working with cloud storage, kubectl for working with Kubernetes, BQ for working with BigQuery. It supports all of these languages in the editor, I think. Or I mean, you already have installed Java, Go, Python in your environment. Then you have web preview functionality and built-in authorization for access to resources and instances. Yeah, because otherwise, if you install locally the Cloud SDK, you will need to manage all the authorization stuff. Learn more about Cloud Shell in the Cloud Shell documentation. Wow, nice. I didn't think that we may have such a resource. This is so cool. Okay. Therefore, after 1 hour of inactivity, Cloud Shell instance is recycled. Only the home directory persists. Any change made to the system configuration, including environment variables, are lost between sessions. Therefore, open Cloud Shell and explore features. In the Cloud menu, activate Cloud Shell. If prompted, click Continue. minimize, restore, open a new window, and close terminal. What the fuck is this? Close Cloud Shell now. Okay, so we open it. We click continue. And here we have the minimize, maximize, open a new window, and then we can close terminal. Okay, so close this. Cloud Shell provides you with each of the following: 5 gigas of persistent storage of directory home, built-in authorization, command line access to a free temporary compute engine VM, a command line tool that requires you to install. Okay, so submit and let's go. Task 3. Use Cloud Shell to create a cloud storage bucket. Create a second bucket and verify it in the Cloud Console. Open and use the cloud storage command to create another bucket. Replace bucket name with a globally unique name. You can append as a 2 to the global unique name bucket you used previously. So I will do this. In Cloud Shell, you can define variables, environment variables, export, bucket name, and I can put a value, which will be this one. With a 2. Oh, so GCP export environment bar. What's function? ChatGPT, GCP Cloud Shell. I want to define export a variable environment, an environment variable. Export my variable. Oh, so double quotes. And is there any space? No space here. Not a valid identifier. Well, fuck this. It's not working now. So I just need to use this command here to create a new bucket, which will be called, oh shit. Sorry, I'm doing a little mess. So I will copy this, put it here. Okay. Authorize. So now we'll have another. Okay. Invalid bucket name. Now, okay, it works. Wow. Invalid bucket name. What the fuck, man? Now we will call it valid bucket name. Oh my God. Jesus. But why there worked, here not? My God, man. So let's debug this. Okay, so bucket names must be lowercase. There are a number of restrictions as well. Different requirements. Lowercase letter, 9 dashes, underscore dots. Maybe I'm putting a space somewhere. No, it doesn't look like a space. Let me see one thing. Bucket name. Man, use a piece of the password also. Jesus, it's already giving the same shit for all the names I put. There's something in the... Okay, my God. My God. I was putting parentheses. Yeah, it was the parentheses. So sorry, losing time on this stupid stuff, but yeah, it happens. Got it, yeah. So it's still not showing here. Buckets, okay, yeah, here. Therefore, authorize in the Cloud Console, click Cloud Storage Buckets, refresh, you can see it in bucket. Check my progress. Yeah. Task 4. Open Cloud Shell, click on the More button in the Shell toolbar to display further options. Click Upload any file from your local machine to the VM. This file will be referred to as my file. Okay. In Cloud Shell, type ls to confirm that the file was uploaded. Okay. So more upload file. Choose. I will upload one of the Google documents. Upload. Transferred. Okay. Where I am. Okay, I uploaded this file here. I wanted to know my location, which is still check your direct, check current directory command in Linux. pvd home student. Okay, nice. Copy the file into one of the buckets you created earlier. Replace with the file you uploaded and bucket name with one of your bucket's name. So the command is this. So we'll copy the minus. Okay, and GCS bucket, it will be this one. I will copy it in the first bucket, the one that doesn't have dash 2. Okay, you have uploaded and copied it to a bucket. Close by clicking on different icons. Close shell sessions. Okay. Check my progress. Great. Therefore, task 5, create a persistent state in Cloud Shell. In this section, we will learn a best practice for using Cloud Shell. The gcloud command often requires you to specify values such as region, zone, or project ID. Entering them repeatedly increases the chance of making typing errors. If you use Cloud Shell frequently, you may want to set common values in environment variables and use them instead of typing actual values. Identify available regions. Open Cloud Shell from the Cloud Console. Note that this allocates a new VM for you. To list available regions, execute the following command. So it's a new virtual machine all the time, using the home directory. So the memory is persistent, the machine is not. Now, select a region from the list and not the value in any text editor. This region will now be referred to as your region in the remainder of the lab. Okay. US West 4. Okay, so I usually use the Windows Note sticky notes. Now, create and verify an environment variable. Infra class region. Create an environment variable and replace your region with the region you selected in previous step. Infra class region. Well, what's this? Something like the export, but specific. Okay, now I can do HO infra class region. Oh, it's even without export, basically. Oh, great. You can use environment variables like this in gcloud commands to reduce the opportunities for typos, and you want to remember a lot of detailed information. Every time you close and reopen it, a new VM is allocated, and the environment variable you just set disappears. In the next step, create a file to set the values so that you won't have to enter the command each time Cloud Shell is reset. So I will create an infra class. Wow, nice. Actually wanted something like this. Create a file called config in infra class directory. Append the value of your region environment variable to the config file. So HO infra class region, infra class config. Okay. So in a line, I will create this line and print the value of infra class region in this file. Nice. Create a second environment variable for your project ID, replacing your project ID with the project ID, the Cloud Console homepage. Okay. Infra class project ID, your project ID. And the project ID is this one. Therefore, append to the config. Okay. Nice. Use the resource command to set environment variables, and use the HO command to verify that the project variables was set. Let's configure. Wow. Linux source command. Linux source command is a shell command that reads and executes commands from a file in current shell environment. File is typically a shell script, but it can also be any text file containing a series of commands. Wow, so cool. This gives you a method to create environment variables and to easily recreate them if Cloud Shell is recycled or reset. However, you will still need to remember to issue the source command each time Cloud Shell is opened. In the next step, you modify the pprofile file so that the source command is issued automatically every time a terminal Cloud Shell is opened. Close and reopen Cloud Shell, then issue the command. Okay, so let's reopen this and what is nothing. There will be no output because the environment variable no longer exists. Modify the bash profile and create persistence. Edit the shell profile with the following command. Okay. Add the following line to the end of the file. Source infra class config. Let me see. Okay. Use the echo command to verify that the variable is still set. But I didn't set it. You should not see the explorer. Ah. What? Hmm. Therefore, I need to close it to open it. Now maybe I will have it. Okay, yeah, now it's working. You should now see the expected value, blah, blah, blah. Is there a corrupt instruction resetting an article, setting Cloud Shell default value, set back to its, okay. To create a persistent state in Cloud Shell, which file will you configure? That profile. Oh shit.
In this lab,
What the fuck, man? No. Okay. Thought I would lose it. Review the Google Cloud interface. Cloud Shell using it's like okay. The Google Cloud and Google Cloud Storage commands can be automated by using scripting language like Bash or PowerShell. You can also explore using the command line tools in Cloud Shell, and then use the parameters as an implementation guide in the SDK using one of the supported languages. The Google Cloud interface consists of two parts, console and shell. The console and shell, okay, and your lab. Great. And lab. It was good. Okay, now we can do next.
In this lab, you created a cloud storage bucket using both the GCP console and Cloud Shell within GCP. The GCP console can do things Cloud Shell can't, and vice versa. For example, the GCP console can keep track of the context of your configuration activities. It can use the Cloud API to determine from the current system state what options are valid, and it can perform repetitive and more leveraged activities on your behalf. Cloud Shell, in contrast, offers detailed and precise control, and through its commands, a way to script and automate activities. However, don't think of the console and Cloud Shell as alternatives. Think of them as one extremely flexible and powerful interface. You can stick around for a lab walkthrough, but remember that GCP's user interface can change. So
yeah, there are things which cannot be done in the shell, or the contrary, things which cannot be done in the console. So my previous experience, yeah, I've seen that you need to know how to use both of them.
So your environment might look slightly different. All right, so here we are in the GCP console, and the first thing we're going to do is create a bucket using the GCP console. So to do that, I'm going to use the navigation menu, which is the icon up here.
So, but the GCP interface can change.
Top left corner, and I'm going to scroll down to storage, which is here, and click on browser. And what we want to do is create a bucket. So I'm going to click the create bucket. And the first thing we need to do is define a name. And now this name needs to be a globally unique name. So you could, for example, use your Quick Labs project ID here. So that's what I'll do. And copy that and paste it in there. The instructions just say to create. You could also choose change the default storage class. It's currently set to multi-regional. We'll talk more about that in a later module. You can control the access to the objects, and there are even some advanced settings around encryption. So I'm just going to go ahead and click create. And you can see that this now has created a bucket, and here we see the bucket ID or the name. So now we're going to access Cloud Shell, and the way we're going to do is we're going to click this button up here in the right corner. It says activate Cloud Shell, and then it'll prompt you to start Cloud Shell, so we'll click that as well. And you can see that's coming up here. You can actually expand this and open this in a new tab, or you could realign this to get a little bit more real estate in here. And so we created a bucket using the GCP console. Now we're going to repeat the same using Cloud Shell. So I'm going to go ahead and copy the command from the lab instructions and paste it in here. Now the command has the bucket name here in brackets, and we want to change that. So this again has to be a globally unique name. And so what we could do is we could again grab the ID of our project and maybe just add something to it. We could just add -shell to say that this is the one that we created from Cloud Shell. So the command is gsutil. These are the commands for cloud storage, and mb is the make bucket command. You see that it has created that here, and we can see if we navigate in the GCP console back to we're going to give the name of the file, so myfile.txt, and the command that's listed in there, gcloud compute regions list. And from these regions, we can now select the region and store that in an environment variable. So just running that, and it's now telling me that and then I run the command from the lab instructions to also append the value of the project ID to my environment variable in the configuration file. So let's modify the .profile file so that the source command is issued, and then you reopen it, and then let's verify. And then we look into some features around Cloud Shell in terms of uploading files, then copying those files to the storage bucket. And in this lab, you're going to experience the power of GCP automation by setting up a complete Jenkins continuous integration environment using the GCP marketplace. You will then verify that you can manage the service from the Jenkins UI and administer the service from the VM.
Experience GCP automation by setting a continuous integration environment using the GCP marketplace. Okay. Now I could accomplish a very similar result with manual configuration in a couple of hours or even days, but this lab you will set it in
VM host through SSH. Now, you could accomplish a very similar result through manual configuration in a couple of hours or even days, but in this lab, you'll see it set up in only a few minutes.
Okay, so let's say if the lab is short, 30 minutes, and there use marketplace to build a deployment, examine the deployment, administer the service. I think we can complete all of this stuff, yeah, in a short time. So let's go, we'll do it. Other 5 credits. Okay, so open incognito window. I will put this password here. Okay. Oh, so you already see it. Oh, fuck. I hope it's not messed up. Yeah, whatever. Okay, let's see. First task, navigate to marketplace, locate deployment for solution. Okay. Marketplace. Let's search for this. Okay. So now it should be click on deployment and read about the service provided by the software. Jenkins is an open source continuous integration environment. You can define jobs in Jenkins that can perform tasks such as running a scheduled build of software and backing up data. Notice the software that is installed as part of Jenkins shown in the left side of the description. The service you are using, Marketplace, is part of Google Cloud. The Jenkins template is developed and maintained by an ecosystem partner named Bitnami. Notice on the left side a field that says last updated. How recently was this template updated? How recently? Okay. Wow, quite recently. Yeah. Google Cloud Marketplace lets you quickly deploy functional software packages by providing predefined templates with which Google Cloud service. I'm not sure. So the service you're using, Google Cloud lets you quickly deploy functional software packages by providing predefined templates. What the fuck? How do I know this? Terraform, template manager, Firestore, deployment manager. Fuck you, how do you know this? Okay. Launch Jenkins, get started, verify deployment, accept the terms, agree. For the pop-ups, agree to terms, click deploy, leave everything as default and click deploy again. Ignore the warning after Jenkins is deployed. Get started, agree, deploy. Okay. Nice. Therefore, I will leave everything as it is. Jenkins 1 is being deployed. Okay, now I imagine it will take some minutes. You will see Jenkins 1 when the process is complete. Deployment Manager is a Google Cloud service that uses templates written in a combination of YAML, Python, and Jinja to automate the allocation of Google Cloud resources and perform setup tasks. Behind the scenes, a virtual machine has been created. A startup script was used to install and configure software, and network firewall rules were created to allow traffic to the service. Ok. ¿Y todo bien? It's being deployed, so check my progress. Let's see, it's saying completed. Examine the deployment. So view installed software and log into Jenkins. In the right pane, note the admin users and admin password values and add them to the text editor. Jenkins has been deployed but contains warning. Yeah, whatever. Click visit the site to view the site in another browser tab. If you get an error, you might have to reload the page a couple times. So site address, continue to site. user, and the password is this one. Sign. Okay. So now log in, not if you get an HTTP error, blah, blah, blah. After logging in, if you are asked to customize Jenkins, click Install suggested plugin and click Restart after the installation is complete. The restart will take a couple of minutes. If you are getting an installation error, retry, blah, blah, blah. Explore Jenkins. Click Manage Jenkins. Look at all the actions available. You are now prepared to manage Jenkins. The focus of this lab is Google Cloud Infrastructure, not Jenkins. So seeing that this menu is available is the purpose of the step. Leave the browser window open to the Jenkins service. You will use it in the next task. Now you have seen that the software is installed and working properly. In the next task, you will open an SSH terminal session to the VM where the service is hosted and verify that you have administrative control over the service. So administer the service, view the deployment and SSH to the VM. On the Google Cloud Console title bar, type Deployment Manager in the search field, then click Deployment Manager in the Product and Pages section. Okay. Click Jenkins, click SSH. Okay, so deployment manager, then SSH. Now I will share with you this third Windows SSH. Okay, great. It looks fancy. Okay, so here. Now, the console interface is performing several tasks for you transparently. For example, it has transferred keys to the virtual machine that is hosting the Jenkins software so that you can connect securely to the machine using SSH. Shut down and restart the service. Okay, so sudo with admin privileges, we go to execute stop ctl script stopping service. Okay, then refresh the browser window. You will no longer see Jenkins. Makes sense. Then in the SSH window, restart the service. Okay. So now we can see it again, imagine. Return to the browser window. You may have to do it a couple times. Type exit. So exit from here. Task for review. In a few minutes, you were able to launch a complete continuous integration solution. You demonstrated that you had user access through Jenkins UI, and you demonstrated that you have administrative control over Jenkins by using SSH to connect to the VM where the service is hosted, and you're allowed. No comments this time. So great, we basically did it. Now, this lab has arrived to its end.
In this lab, you were able to launch a complete continuous integration solution in a few minutes. You demonstrated that you had user access through the Jenkins UI and that you had administrative access control over Jenkins by using SSH to connect to the VM where the service is hosted and by stopping and then restarting the services. Many of the activities that occurred in that lab were nearly transparent, and they used resources and methods that you learn about in the rest of this course. Examples of this include the acquisition and configuration
And they use resources and methods that you learn about in the rest of this course. Okay.
of a network IP address, the provisioning of a virtual machine instance along with the installation of software on that machine, and the passing of default state information from the environment during the setup process. You can stick around for a lab walkthrough, but remember that GCP's user interface can change, so your environment might look slightly different. So here I am in the GCP console, and the first thing I want to do is navigate to the marketplace. So up here I've already clicked on the navigation menu, and marketplace is pretty much on top. So I'm going to click on that, and now I want to search for Jenkins, specifically the one that's certified by Bitnami, so I can just directly paste that in the search address here.
It's the same.
And here we go, this is the one I'm looking for. So I'm going to click on that. Open. And we can see that that service is getting ready right now. And so at this point, we've completed all the tasks. I can now go back to the SSH session and exit out of here. And here we see that Jenkins is back up and running. And that's the end of the lab. Let's explore projects, which are the key organizer of infrastructure resources, and relate these resources to billing accounts. Resources can only be created and consumed within projects, in a way that projects isolate related resources from one another. I will demonstrate how to create and delete projects and switch context between projects. Some of these actions cannot be performed in the QuickLabs environment due to security restrictions. Therefore, I'm going to demonstrate them in my environment. So here I am in the GCP console. You can actually see this as a trial account, and you can also create a trial account yourself if you would like to follow along with this. Essentially, what I'm going to do first is go ahead and create a project. So I'm going to click up on my project name up here, and there's this icon up here to create a new project. So let me go click that. And now the one thing I want to do is I want to define a project name. Let me just say my new project. And you can see that it automatically creates the project ID, and that project ID is going to be unique versus my name is really not so unique. So let me click create on that. And it is now telling me here that it's going to create that project. I can follow along with that here in the notification pane. And one thing to notice is when you create a new project, that some of the services that you're going to use may not be initially available. So here I now have my new project. I could now switch projects. So if I go to my home, for example, I see here the project itself. I could go to the project settings. I could shut that down, or I could switch to a different one. So let me actually change up here to this new project that I created. We go in there, and let's follow the process for shutting that down. So I'm going to click on shutdown. Now I want to make sure that I really want to do that. It's telling me a little bit about what's going to happen when I do this. Specifically, all billing and traffic serving will stop, but the shutdown is actually scheduled, so it will take 30 days, and this is in case that you want to maybe undo this. So I need to just retype my project ID, and I can actually copy and paste that in here, and I can click shutdown, and it should now give me a notification. So here it's telling me when exactly it's going to shut this down, and I can click OK on that. So now this is being scheduled for shutdown. So now I can go back and obviously want to grab a project. It's automatically putting me in the site. Alternatively, if I go home, you'll see that I also have an option up here. It's telling me, hey, you really need to select a project. So lots of different ways to go about. So I can click on that and select a project. Now, I want to show in a second how we can also maybe switch projects once we're in Cloud Shell. So let's actually go ahead and create another project. And let's just call this my second project. We can create that as well. And they'll start in the background for us. So what I want to do now, as I said, I want to go to Cloud Shell. So if I go up here in the right corner, it says Activate Cloud Shell. Just click on that. It doesn't ask me if you sure want to start Cloud Shell because I've already been using Cloud Shell with this user. So it's also telling me that I haven't used my Cloud Shell in a while, so it has to unarchive my disk, and that's going to take a little bit of time. But once that's up, we can actually go use the gcloud config list command, and we can paste that in. It's going to give us more information about the configuration that we currently have, and that will include the project that we currently have selected. And you can actually see the project right here. This is the project I'm working on right now. So if I paste in, I automatically copied that when I clicked on it, so I want to instead type in here gcloud config list. So here we get some more information, and I can also use the grep command in here to directly get my project, and there we see this is the project that we're currently using. Okay. I could actually now even change the focus of my GCP console to this new project, and you'll see if I run this command again, my focus of Cloud Shell is still focused on this other project that I had. So one thing we could do now is we could store the project ID maybe in an environment variable, and then we could maybe set it so we could kind of swap back and forth. So let me get the project ID, it's right here, and I'm going to maybe just store that in an environment variable, and let's just call that my project ID 1. So let me grab the project ID, copy that, paste that in there. So now I have that stored, and now I could use the gcloud config set project to define an action to change the project ID. And now you can see that I have that other project ID listed here. Okay. So I can actually see that. And I could also now use the same gcloud config list command and grab the project, and you'll see that now I'm working on this project. That's how easy it is to.
An easy question in the exam. Configure set project ID. So which of the following does not allow you to interact with Google Cloud? Cloud Explorer, which I'm not sure what is that. What is the difference between the Google Cloud Console and Cloud Shell? Cloud Shell is a command line tool, while Cloud Console is a graphical user interface. Cloud Shell is still locally installed? No. Cloud Console is a command line tool? No. Great. So now we completed this module basically. We'll have the review.
In this module, we looked at how to use GCP, which you got to experience firsthand in 2 short labs. I also gave a demonstration of how to use projects, which are the key organizer of infrastructure resources. Now that you can interact with GCP, it's time to explore 2 of the foundational components of GCP's infrastructure, virtual networks and virtual machines. So what are you waiting for? Move on to the next module to learn more.
Great. Therefore, we already finished this section, which was just an
In this module, we
introduction on how to interact with resources, which options we have. And the next video will be about virtual networks. We'll have 2 labs, and we'll perform different type of exercises. Therefore, I will just close and see you in the next video. It was a pleasure as always. Thank you very much. Bye-bye.